everybody to today's webinar, R4 Resilient Residential Retrofit and Reconstruction. Today's presentation is brought to you by Open Architecture Collaborative, the AIA Housing Knowledge Communities, and EDI International. I'm your facilitator today, Tommy Burns. I'm an architect in Boston, graduate of Roger Williams University in Rhode Island. I've always had a strong interest in international community development, public interest design. Worked abroad myself in Haiti, studying safe housing practices. So I am very interested in today's presentation. Our presenter today is Illya Azaroff. He is the principal at Plus Lab Architect, and he is an associate professor at NYCCT. He serves as subject matter expert to ASPR on the Federal Disaster Recovery Framework and works with ORR, New York City Office of Recovery and Resilience, and the Department of City Planning. He was awarded the 2014 Young Architects Award and serves on the AIA National Strategic Council. He's a founding co-chair of DFRR, Design for Risk and Reconstruction, and is an instructor with the NDTPC, National Disaster Training Preparedness Center. He is a certified trainer by Cal EMA SAP Safety Assessment Program. His work on resilient buildings and structures is well documented, currently engaged with FLASH, Federal Alliance of Safe Homes, building a demonstration hashtag Hurricane Strong home in Queens, New York. Prior to New York City, he worked in Germany, Italy, and Holland. He has his master's from Pratt Institute and undergraduate degrees in geography and architecture from University of Nebraska-Lincoln. Quite a resume. Today's learning objectives, attendees will gain an understanding of how to recognize resilient and sustainable building methods that can synthesize and coexist to contribute to a better holistic building. We will learn where to find and access various resources and best practices for use in their own practice related to resilient residential building and design implementation. Attendees will also learn about and gain access to beyond code benefits and measurable material outcomes, along with testing results illustrating risk reduction measures for residential building design and construction. And attendees will learn how to incorporate resilient best practices in existing residential retrofit projects, including those in historic districts and in risk areas prone to flooding. Being in Boston, a lot of our cities in New York, we all, I'm sure, can relate to this. In our course description today, architects are being asked to understand where and how to build better in the face of mass migration, population growth, resource stress, and associated risk posed by natural disasters and climate risk. The AIA and its members are at the forefront of addressing these issues, highlighted by a commitment to the new urban agenda that aims to provide quality housing to people and communities around the world. Here in the US, we are coming to grips with the transformation of communities and the way we build to ensure the health, safety, and welfare for all. In this webinar, Illya will take you through a series of housing projects that directly address risk through resilient adaptation and beyond code building practices. He will introduce several relevant resources covering residential construction and retrofit to achieve resilient building design and benefits to the stakeholders. If you have any questions today, please submit them to the chat box. Should be on the right-hand corner of your screen. Any technical questions will be answered as soon as possible and content-related questions will be answered during the Q&A towards the end. Today's presentation is copyrighted, protected by the U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of the speaker is prohibited. And please take a moment to look over the compliance statement on the following screen. And thank you, Illya, for joining us today. Really looking forward to this. Take it away.
Thanks, Tommy. Thanks, everybody, for having me. And I understand we have a pretty good crowd today. So I'd like to start off with a few issues at hand. It's really important that we really set the framework for what we're doing. And some of those issues happen to be that the world is getting a lot hotter. Last year was the hottest year on record, and no doubt this year we'll probably break those records. But that means more flooding, more heat, more issues that we have ever had before. And in fact, in the United States, 80% of Americans have been hit by extreme weather since 2007. And if we took a look at just last year in 2016, that was the most billion-dollar disasters in U.S. history, coming in second only to, I believe it was 2011. If we take a look at some of the other issues at hand, some of it has to do with rapid urbanization. In 2010, half the world lived in urban areas, and by 2050, 70% of folks are going to live in urban areas. Accompanying rapid urbanization is where will people be moving? And that has to do with where our cities are located. If we take a look at some of these diagrams, you see that most of our major cities in the United States happen to be in coastal zones, but that's worldwide. We have an issue that most cities historically have been located on water bodies for various reasons, and folks are moving towards those. But what has happened in these, coupled with climate change and rising sea levels, you can see by these diagrams alone that we have multiple areas at risk in our riverine and coastal areas, drainage basins, all the way down to New Orleans, where more and more people are moving. So how do you address increased populations and more limited land use with these issues? Other issues at hand have to do with resource scarcity. That little dot all the way to the right of your screen, that is how much water is shared by 7 to 8 billion people on the planet today. That 0.08% is of less than 1%, of less than 30%, of less than 2.5% of the fresh water available in the world. And as populations increase and cities are threatened by climate change, we already have that recipe for ongoing disasters. And in fact, if you look at the accessibility to clean drinking water today, 2.3 billion people do not have access to clean drinking water on a daily basis. That's an enormous amount of the world population, and that's only going to get worse. In fact, 3 out of every 4 jobs happen to be dependent on water globally. That means that 75% of all labor in the world is dependent on water. Too much water, too little water. Sometimes we get caught up in a little bit too much. With New York City, where I live in Brooklyn, a lot of the work that's being done is around these predictions, proved forth by Sandy, that we're going to be looking at almost 6 feet of sea level rise over the next century, and how do you prepare for that? The fact is, over the last 30 years, the world has lost 2.5 million people to natural disasters at the cost of $4 trillion. If we look at the year of Sandy in 2012, that year, 61 million people, just over 61 million people, were displaced worldwide from natural man-made disasters. And so we hear a lot about the crisis that's going on around the world today with population migration. That's been happening for years and years, and it will continue to happen. In fact, every minute, 24 people are displaced around the world by natural and man-made disasters. So when we think about the AIA and the New Urban Agenda, and we talk about housing today, we need to think about this in a global context. Will we have places such as this image, where you have housing at an unforeseen rate with little regulation, little safety, security, sustainability, or health, safety, and welfare versus what's on the right of the screen. But what we really need to do is project forward to the years 2050 and 2100 and ask ourselves what the future will hold. If we take a look at that, global migration and growth of cities combined, you will have an estimated 200 million people in need, estimated by 2050 on an annual basis. And if you look forward to 2100, that estimate goes up to 550 million people on an annual basis being displaced by natural man-made disasters. And folks from Swiss Re and other reinsurers really look at the cost of what that would be to the worldwide economy. That's $200 trillion that needs to be spent or will be spent on repairing our cities and taking care of displaced persons from natural disasters in the coming century. So what does that mean? Well, what does it mean if I bring that back to, say, New York as a case study? Well, what that means is that since 1953, there's been 3,600, a little more than 3,600 disasters declared in the United States. And these are federal level disasters. And if we look back at 2016, that was 103 declarations. Dialing that into New York, so when I'm designing a house, I really need to look at what the issues at hand are for that community, for that area. So if we take a look at just these maps of New York, since 1953, 27 national declarations just based on severe storms, 23 just based on floods, 18 based on snow, 12 based on hurricanes, and again, we're newly discovered as a hurricane zone. So you have to look at all hazards when you're looking at housing in the future and communities in the future. Now, if we look at New York City proper, the 5 boroughs, in the 5 boroughs, we look at our current coastline, but project again forward to 2100. And if you look at that erosion of coastline based on daily flooding, as well as sea level rise, that equates to about 12 square miles in land lost. But this is highly dense area of an urban environment, similar to Boston, similar to all of the cities along the coast, Miami, all of these places. So what does 12 square miles mean for New York City? Well, it means about 400,000 people who currently live there can no longer live in those locations, or we're going to have to do a lot of extreme work to keep them in those locations. Aside from those 400,000 folks, that area of land turns out to be quite a large chunk of the city if you gather it together and remove it from the geography at play. But as a side note, 51 square miles of New York City, the 5 boroughs, was hit by Hurricane Sandy. So we've seen this before. We've seen it even worse. But this is on a daily basis based on climate change numbers. It's 12 square miles. And within those 12 square miles, aside from those 400,000 residents, it includes 80 schools, 74 daycare centers, 28 public housing buildings that house 61,000 people alone, other residential facilities which have social services, 18 hospitals, 9 senior centers, 4 water treatment plants. So we are talking about housing today, but we're also talking about everything that supports the infrastructure of what makes a community and housing work in those locations. And with the new urban agenda, a walkable city. So is this our current response? This is what we're at now. Does this look like long-term thinking? Well, if we need to recognize a couple of things, the consequences of uncoordinated action. When I'm working on a house, I need to really understand what the neighbors are doing. I need to understand what's happening with the entire community altogether. And in fact, if you look at the rates of insurance, this is what's happening all across the Northeast, in fact, all across the country. If you look at this diagram, this is based on a $250,000 home. If you do nothing and you are considered in a flood zone, you're looking at almost $10,000 a year paying out insurance. If you do minimum compliance, which is to the BFE or the base flood elevation, you're at $1,400 a year. Stark contrast. If you take the recommendations of Freeboard and go to a design flood elevation, which is much higher, your insurance drops really, really far. Now, a lot of people can't get to compliance, and that's some of the issues we have. what we see are resilient communities. So how do we get to this idea of resilient communities with housing at the core? Well, in this diagram, you can see everything from flood basin and wetland relocation, elevation, ecological restoration. This includes relocation of housing. Traditional housing along the coastline in New York City, those 12 square miles that will be inundated over the next 50 to 70 years, we really need to rethink where those folks are going to live, where we're going to build, and how we build a better building. If we think about a layered approach, we need to recognize that resilience is health, safety, and welfare as architects, but the holistic building approach tells us that building resilient and sustainable together can coincide, but they are quite different in some cases. Sustainability, looking at long, slow change in environmentally alignment, and sometimes resilience is based on redundant systems and trying to become risk adverse where it's not aligning with the environment. It's really environmentally defensive. But there's many instances that we'll go through in case studies. If we take another approach, this idea of layers starts well outside your building. Your buildings and grounds, bioswales, rain gardens, how do you manage what's going on to keep a cooler environment when it's extreme heat, or taking care of water when there's too much or when there's too little? Now we get to this idea of whole buildings. So I'm going to give you a series of diagrams that lead you into these three case studies. The first is whole buildings or new buildings in Zone A. Zone A is a floodway or designated flood zone. And we know these best practices through members of the AIA, through thought leaders. And this first slide is put together by Don Watson. And you're really looking at renewable energy, photovoltaics. You're looking at how you treat the roof, natural daylight, passive survivability, redundant energy and communication. How do you make the shell of the building adverse to flying debris? And how do you have islandable power and smart systems that help you stay safe before, during, and after a disaster? But the challenge is, as stated on the slide, 80% of our buildings will remain by 2030 and beyond to 2050. So it's really about the next slide, which is retrofit strategies. How do you really address those 80% of the buildings? A holistic approach to mitigation strategies. A lot of the things in this slide are the same as the prior slide, but the challenge is meeting the new energy code, meeting these other issues while making it much more robust, anchoring and securing areas of buildings that are perhaps well beyond in years. And that brings us to our first study. The first study is a historic West Village townhouse retrofit. And here's a location in Manhattan, for those of you who are not familiar with the area. But this historic district is low-rise. If you take a look at, here's the facade of the building. And this is traditionally a three-family structure, 4 stories above, 1 story below, or a cellar below. And some of the issues that you run into with these buildings are, how do you make this holistically safe and secure? And we're going to go through a little bit of that. Part of the things that we have to deal with or contend with these historic buildings is the fact that we can no longer directly put rainwater into the rain sewers because the system is overloaded in New York City. So you have to find a way to, one, protect from backflow from the sewer, but also then hold on to your water. So in a lot of these cases, we've had to do sumps and pumps, overflow, check valves, as you see here, but also be able to somehow hold on to the water until you can later release it. Very difficult in these small footprint buildings. But on to the next slide, some of the strategies that we do take on is how do we take these buildings and turn them into much more passively survivable buildings, increasing the insulation value from the inside out, but also changing the interior footprint. And in this case, we sank a elevator shaft down the center. And the elevator shaft is used as a core ventilation into a skylight. The skylight is allowed to have a chimney effect and vent, but also allowed to passively heat the upper portion of the building and then redistribute that air to other parts of the building. So that's part of the pieces. And you can see that we've added on the rooftop a backup gas-powered generator Natural gas fared very well in Hurricane Sandy, and this unit that is shown here on the roof is jacketed with flying debris, and all the connections and services are hardened for flying debris, and we hope we never have to bring it online and use it. The last slide for this project really looks at some of the pieces that in any historic district you need to really look at. First and foremost, we added new windows. These are impact-resistant windows, but also that increased the thermal performance, as well as the operability for the passive measures were increased. Oddly enough, we also had found windows with a high STC value, creating a lot more comfort on the street side with a lot of traffic that had gone through this area of town. In addition, we expanded the stair bulkhead that includes relocation of mechanical and generator to the roof, as well as in the cellar. You can see that it's a lower flood area. We elevated the other equipment. So if there is water that is beyond the holding tank capacity, that there is yet another layer of redundancy or safety and security within the building. If as sea level rises and this building becomes more vulnerable, the next stage would be is the access to the cellar itself could be built up on the street side with water barriers that actually happen to be fixed planters. And what I've also listed on this slide is if you take a look at one of the resources that's available to you is the FEMA, the acceptable materials that are within flooded areas. And there's a whole list of these, and not just these, there's many more. So take a look at Technical Bulletin 2 when you're looking at retrofits and rebuilding areas. So on to the next piece of this. Where are there opportunities? So opportunities exist in a lot of ways, and part of it has to do with innovation. So I show you this slide about innovation in all forms because I talked about water earlier briefly and how precious it is, too much or too little. And designers all around the world are tackling these issues about water, and we should too as architects. The other opportunity that is out there, we need to recognize that by 2030, 900 billion square feet of new and rebuilt buildings will be constructed in cities around the world. That happens to be 3.5 times the entire building stock in the U.S. currently. So that takeaway is that every one of you listening has the opportunity to change this conversation, but to make things more resilient and sustainable that will move the world in the right direction, city or project by project. And the next piece really is it's all of these pieces of the new urban agenda and questions that you have. But the core takeaway here is that housing is the core of adaptation. It's not just the large buildings, it's really the small housing pieces. And here's one piece that we did implement on the structure that I showed you in the West Village, is how do you take care of water in a positive way? So we recognize this as an opportunity, and if you take a look at New York City, 20 by 50 footprint of the building gives you a great opportunity to gather almost 6,000 gallons of water per year, nearly 500 gallons per month. That's including some waste and non-captured water. But that gives you an idea of what can I do with that? Well, there happens to be a community garden in the back of this house that was contributed to. So how do you take that onto a larger community impact of 10, 20, 50 homes? You're solving some of the larger problems of the world. So case study 2, I'm going to take you out to the Rockaways, or Breezy Point. So this is a little bungalow. You can see this peninsula of the Rockaways. It is only a few feet above flood elevation. And by the insurance flood map, you can see that this is inundation territory. So the first piece of information we're going to use is the retrofit buildings for flood risk put together by the Department of City Planning. This has all scales of housing, from the bungalow all the way to multifamily. And within that, I'm showing you 2 pages here on this next slide that is just the bungalow and some of the requirements that are there, but also what's available to the homeowner to keep them safe and secure for many years to come. And so now I'll show you the bungalow that we took on out here, one of the many projects that we've had. So this small bungalow is about 630 square feet. Our understanding is that it was built in the 1940s, and this is a shot of the bungalow that's just after Sandy. Some of the debris has been taken away, but the water line was about mid-window. And everything inside on the single story was completely inundated. The next slide shows the west elevation. This is sort of our demonstration plan. That red line running through there is the freeboard requirement. So I told you what the design flood elevation. The design flood elevation is what's required by your flood maps, and the city should be putting out information or finding those through FEMA, but then a freeboard is added to that. Projected sea level rise, wave action, whatever it may be. In New York City, it's generally 2 feet. So that red line shows you where the finished floor should finish above that line. And so this little bungalow is being raised quite a lot. Next is just a typical shot of an elevation certificate, understanding that you need to go through several processes of a lot of these homes that don't have good documentation. And then there's several shots of the crew lifting the house. We hadn't done any lifts as an architecture firm. I'd seen them on occasion. But what you're going to see is that cribbing and new ways of lifting, many of you listening might have experience with this, but the city of New York didn't have a lot of this. And in fact, a cribbing drawing was required by architects, which you can see here. And the cribbing drawing is something that we had never done before, and neither the city had not seen it. So our cribbing drawing became part of what the city has used on occasion as an example. Typical cribbing of lifting these little houses is steel and jacks, and this little hand crank jack, oddly enough, does the job for this small house. And as this thing gets elevated piece by piece, you can see these next group of guys digging out an elevation or digging out the foundation. Concrete reinforced grade beam that elevates the house with concrete reinforced piles. And this thing goes up in the air, very much like our original drawings. The next slide, though, shows the elevation of the house. And here's a couple of technical bulletins that you should be aware of. When you are doing house lifts, it's not just lifting the house. All the utilities that come up into the house, to make those resilient to waterborne debris and flying debris, there is guidance for that in the schema document, the protecting building utilities from flooding and damage. And there's some details that are provided. And then, of course, the enclosures. So once you elevated this house, depending on how high it is, you have to make some sort of breakaway enclosures that allow the water to come through, but also, if it's hit by debris, to not put unnecessary forces onto the new structural system that you put together. So this is a good resource slide that we'll share out with you. And the next slide just sort of confirm, as the house went up, finishing the house with the columns, and then we'll show you the last 2 slides that really show the front and the rear of the house. So this slide, I did want to mention that because these are tied lots, there is a need for non-combustible stairs, and so you'll see in the vocabulary in a lot of these neighborhoods. And so this last couple of slides really shows how we've mitigated the front of the house to the walkway, so it still has a humanistic feel, and then the rear of the house is elevated like a deck. But I've got to ask, is this resilient? Because in my mind, it's not. I've elevated a home that does not meet the current code standards, energy standards, or any standards whatsoever. We did not replace windows. We did not verify continuous load path. What we were required to do is lift the house and get its services together. So if the next storm comes, I don't expect the top of this house to fare any better in a windstorm than it did in the water storm. That's unfortunate. Case study 3, going on to new construction. New construction happens to be probably the easiest thing that you're going to look at in any of these places. And again, we are back in the same neighborhood. This is on the Rockaway Peninsula, and many of the houses were taken down after Sandy. They just took one, weren't savable. And so this is one of the houses that, if we zoom in a little bit closer to Breezy Point in this neighborhood, and some of the pieces of information that we used to take this house are some of the hurricane-ready information you'll find from the American Institute of Architects, from Hurricane Strong, and that happens to be from the Federal Alliance of Safe Homes, and some of the information that we presented in the first project from the New York City Department of City Planning. So let's take a look at some of these resources. On to the next slide. Here's Hurricane Ready. That's from the AIA. The next slide is the Resilient Design Guide for the Federal Alliance of Safe Homes. And then the next one, which is quite important, is the Fortified Home Standards from IBHS. So the Fortified Home Standard, this is something when you look at the business case for resilience. IBHS does a lot of material testing, and in fact, when you take a look at your hurricane-rated doors, impact-resistant windows, whatever they may be, they've gone through a testing program, usually through IBHS. This fortified standard brings a lot of those together in building methodology that will ensure the house is much more safe and secure. But the best thing is, if you follow these standards, which are beyond code, the insurance rates for your buildings and the end user drop substantially. So we are going to be using the Federal Alliance of Safe Homes recommendations that we had shown you, the elements of the AIA, and the fortified standard here, along with some of the best practices out there for this case study. So here is, the next slide shows you what the house looked like beforehand. Again, this is a bungalow area, but this is a much larger home that was developed by the owner's father. The owner's father was an engineer, and so this building was actually fairly well built. Its structure was intact, and what happened was this building survived Sandy. It was inundated, so lost a lot of its equipment and whatnot, and it wasn't going to be torn down, but upon further investigation, some of the underlying structural beams had cracked over time, and they decided, based on the age of the house and then what was left, they decided to take it down. The next shot is the rear of the house. You can see that this was one of the original bungalows or smaller homes, about, as I said, I think 1,100 square feet. And the houses around it over the years have been developed into much larger structures. You can also see these are all tight neighborhoods that you see in a lot of our cities around the U.S. What we decided to do for this house is bring in a lot of the industry partners, as well as use all of those recommendations to put together a home that demonstrates resilience and sustainability, how it can be attained by the common homeowner, along with using methods that are not so foreign to the general contractor. So there's a coalition that was formed with Portland Concrete Association, BASF, Federal Alliance of Safe Homes, Engineer Woods from Huber, NJIT has come on board to help us out as well. And we designed this home, if you look at the next slide, to answer a lot of issues. So this is a resilient, sustainable home. That's our primary concern, is to give the homeowner something that she will feel much safer in. It's beyond code. It's prepared for extreme heat, cold, wind, water. Also has lighting protection. It's protected against flying and windborne debris to a great degree. And some of the aspects of its construction, it's insulated concrete formwork construction. I'll show you shortly in some slides. It also has hardy plank on the exterior envelope, but also it's concrete roofing tile, which give it an impact resistance along the entire envelope that make it worthy of hurricane force winds and flying debris. The windows and doors are also impact rated for hurricanes, as I mentioned, to have lightning protection. Resilient materials and finishes, as I mentioned, the very first project under FEMA Technical Bulletin number 2, the whole list of materials, anything that is underneath the floodway is finished in that manner. So it's easy to clean up, mold resistant, and no problems will happen in the future. There's also a lot of passive design strategies as well as environmental strategies here that really keep this going. And the other thing is there's backup pieces that go to this, such as a backup generator, but also we decided to go with a higher freeboard. a 3-foot freeboard. So I mentioned to you the design flood elevation. That's what the city requires or the federal government requires, plus a factor of safety. We added an extra foot here just to bring not only insurance costs down, but also the peace of mind of a much more resilient and sustainable house. So if we take a look at the next slide, this is just a brief piece. All of those things I mentioned have to be done in a contextual zoning and contextual building requirement based on the Breezy Point Cooperative. So this house cannot look so dissimilar from the houses that have existed there for the last 50 to 100 years. So how do we do that? Well, luckily there's a lot of good products out there that make that happen, but if you take a look at these next few slides, we just look at the ICF construction. So the insulated concrete formwork gives us a great deal of R value, but also impact resistance. It also stops any noise transmission that was also a concern on the front end of the street, as well as the passiveness, the passive ability of the heating and cooling of this house. The next slide shows you how this product or methodology is put into place. And most of you that do larger buildings, this is not just so dissimilar to what you've done in the past. And maybe a lot of you have used ICF. ICF seems to be, in our minds, it answers the 80 by 50 requirement or the energy requirement that we're all going to need to answer, because this is going to be a very low energy using home for heating, cooling, lighting. All of those passive pieces are in there, and it's due to this material. Then on to the next slide. This is starting to show the house in more complete way. But what I'm showing you with the red line is Diane's house is elevated to 3 feet above the required elevation for a design flood elevation. All of the things that we're doing also lower her insurance, but also increase her ability to withstand shocks and stresses of all of the things that we've listed prior to this slide. But if you take a look in the neighborhood, none of the rest of the homes, as far as the eye could see, are in compliance. So that puts a real stress on this neighborhood. She will be the last house standing if another storm comes in. We don't want that to happen. We want this information to get out to a lot of practitioners. So here's the challenge is, it's education of all parties, not just the architects here that are listening. Many of you know how to do this already. Sustainable, resilient homes. How do you pull that together, and how do you convince communities and contractors who've never built in this methodology before, or only have built in this methodology once or twice? So this house is due to be complete in the next month or so, and so stay tuned. If you log on to Federal Line Safe Homes, it's a not-for-profit organization. They've set up a camera. You can see Hurricane Strong home being built on a daily basis, and log in. We're going to be releasing all the information for this house as open source, plans, drawings, specifications, you name it, because we want the word to get out there. So this brings us to the resources for the design professional. Some of those I've salt and peppered throughout this entire presentation. That information is all free and downloadable as PDFs. You can find it where you need to go. But if we move on to the first piece, here's a few steps for coastal design. Now, a lot of you listening may not be at the coast, but if you're in a riverine area or floodway, it doesn't change. So one, you need to assess your risks, all hazards. Even if you're not in a zone with a lot of flooding, is it extreme heat, is it extreme cold, what is it? Is it earthquake zone? You also have to know what those zones mean and find your flood elevation through the FEMA website that has all of the mapped flooding areas in the United States. They're updated, and you should check with your floodplain manager. You need to calculate your base flood elevation and know the topography and what is surrounding your site and building to make sure that flying debris or other developments may increase your flooding or other hazards for wind-borne debris. In our case, we've been adding our 2 feet of freeboard as a minimum, and then, of course, advocating to go higher if that's available to us through the owner or the city. When you add that, you arrive at your design flood elevation. Then what you need to do as an architect is project into the future. You need to understand what the best data is for what's going to happen with that client, his or her needs over the course of, if it's their 30-year mortgage, then what is climate change in the next 30 years for the area you're designing? That is your ethical responsibility. But if this is a multi-generational house, if this is going to go future or is it an investment, how do you project forward and how does that become part of the return on investment? You also need to look at the community and regional resilient measures in the works so you are part of it. It's coordinated with what is happening, but also unlocks dollars that are available to you. So the next slide shows you some things are already here. If you're in a state that's already adopted the latest code, the residential code already has a lot of these measures baked into what you need to do. But if you move on to the next one, the already modified code for the ASE 24, you already have to have a 2-foot freeboard in VSE. Your lowest floor is already stated where it needs to be. With healthcare facilities and resilient buildings above 5 stories, there's already guidance that it's made its way into the code, so it's no longer guidance, it's actually code. So being aware that this round of code compliance has added some resilient measures, the next one will add even more. So when I say beyond code, you're ahead of the curve because you'll have to do it eventually. And the next piece of information you may want to bring to your own community is the CRS, Community Rating System. So this is a community-wide effort. If you're in a small town, this makes a lot of sense. If folks sign on to this and the community begins to do comprehensive measures, and some of these are very easy to begin with, your flood premiums and your insurance rates community-wide drop at 5% for every point you have. So you can come down to 45% of the discount for a community. So if I look at that in terms of development for the future of my community, and I can roll into that return on investment by reducing my risk and taking that money from the community and looking at what could be better, it's a pretty good program. Then there's a whole list of FEMA manuals. And I'm not going to spend a lot of time on these. There's an entire suite of FEMA manuals that we've built a lot of these things to, these houses to the standard or used. So this is the FEMA P55 Coastal Construction Manual. FEMA also runs a course on this, but it gives you all the base information. If you are building in a coastal zone, which many of you are, this is your go-to for single and low-rise multifamily homes. The next one is the Homeowner's Guide for Retrofit. Since we're using a lot of existing building stock, you will need to understand where to find this information and also pass it along to your clients and colleagues and other homeowners. This gives you a lot of great information on what can be done with existing structures. The next one is the Home Builder's Guide to Coastal Construction. This really shows you how to elevate a house, or really talks about how you and has very detailed sections and structural elements that gives you facts that provide this technical guidance and recommendations all about the construction of these homes and buildings within floodways. The next one is the P805. This is protecting your home from your home and property from flood damage. This gives you even additional information about how to dry out, cleaning for mold, permitting, contracting, and selecting. So if a disaster does hit, this gives you a lot of information on how to get up and moving again for your community, but also as an AI leader. And the next one is from Enterprise. This one's ready to respond. So for those of you that are doing larger buildings, larger multifamily, which we've engaged in as well, and I didn't show any today, but this one gives you 19 practical strategies for existing buildings and owners to make their buildings more resilient from the effects of extreme weather. That means extreme heat, extreme cold, flying debris, wind, all of those things. This is an excellent document that you should get a hold of right away. And one that just recently came out, I was happy to participate in the formation of this. This is the Office of Resilience from the New York City Mayor's Office. It's about the Climate Resiliency Design Guidelines. So again, it's guidance, meaning beyond code. But the city will begin requiring all city or funded projects to adhere to these guidelines. Those guidelines will eventually become code as our minimum standard. But right now, to get ahead of that curve, you have a lot of governing bodies putting this information out there. So here's another great piece of information that if you're going after government work, you'll need to understand what this is, as well as the FEMA documents. If you want to do buildings that have funding from that side, you still need to know these things. And then, of course, there's another great resource, which is the AIA national website, and there's a National Resilience Initiative. You can look on this map, and there are all of these wonderful national resilience members, and these are institutes that have partnered with the American Institute of Architects in areas of the country. So you have in Minnesota, in New Jersey, and all around a place where you can go and get additional support or aid. So if you harken back to what I mentioned about the house that we're building, we brought NJIT on board. NJIT houses, it's the New Jersey Institute of Technology, houses a resilience center. So their students will be monitoring that one family new construction over the next year after it's completed to understand its energy consumption, understand how to make it even better than it is for the next round of housing. So these resources are available to you. And this is a resource that I put in. This is the Homeowner's Handbook. This is something that's put together by Sea Grant, and a friend of mine, Dennis Wong, helps write a lot of these. If you're in one of these areas that has one of these, you should be distributing this to all of your colleagues in local government or contractors. And if you don't have one, call them. They will come and write one for you. And then, of course, there's studies and testing. This is if you're interested in flood proofing in coastal zones, this is put together by David Burkus. And there are 12 types of flood proofing for foundation and underground conditions that have already been proofed out. And most of this is in the Southeastern Compact of, I believe, 8 states that have adopted this. But we've introduced this here in New York City and used some of this methodology here when we're flood proofing below ground. And the last slide that I have for you in terms of resources, this is the ORS list. This is the peer organizations that organizations addressing resilience and sustainability. This is an ever-growing list that is maintained by Donna Watson, FAIA, and it's hundreds, if not now thousands of organizations across the country that if you need to connect to someone locally to get more information, you will most likely find someone or someplace on this list that can assist you in moving your projects forward. And that brings us to the close of what I have to tell you today about these 3 projects. And I did speed through the 3 projects very quickly, but I did want everyone to get a sense of these 3 scales. There's a lot more to be had in the governance and guidance that I put out there for you, and I thank you very much. And if you need to contact me, I'm always happy to answer any questions via email or otherwise. Thank you.
Thank you very much, Ilya. That was great. You shared a lot of good resources. We've received quite a few questions about having access to these resources afterwards. The whole presentation will be available to be downloaded in a follow-up email. So we'll be sure to maybe break out a list of these last resources you shared as well. So, Ilya, one question just came in that's pretty interesting. It looks like someone who worked in Breezy Point. They say, did you come across any issues meeting maximum building height requirements in the Breezy Point case study? They were noting that in the past, the city has responded positively to if they go above the freeboard, they provide more allowances, and wondering how often do you see that communities are being incentivized to build resilient?
Well, that's a great question. So there are two pieces of that. One, yes, you can go beyond the maximum building allowable height. That was one of the first things that under Mayor Bloomberg he put out immediately after the storm, noting that people would have to relocate their services and equipment to new locations. And that's usually for taller buildings, but in these lower-rise neighborhoods, we've run up against maximum height issues, and it's been pretty easy to allow us to go a little bit higher. In the case that we showed you, in both those cases, we didn't break that plane, but some of our neighbors have done that, and so that's one of the pieces. The other question there is about incentivizing. that is a lack of what's been happening in a lot of the neighborhoods. There isn't enough information or incentive to really move towards resilience. A lot of folks just want to think it's okay to go back to the way it was, or build to an existing standard as replacement, rather than really looking at what's happened. So the incentive isn't there, nor is the strong communication or message from the community leaders, unfortunately.
Yeah, and that another question we had was about the architect fees, and do they reflect this additional work? And it seems like there's definitely a lot of additional design and engineering required. And I would imagine a lot of these people who are in the Rockaways, it might be hard for them to find that money. Do you have any comments on that?
Yes, there are some additional services necessary and additional drawings for a lot of this work. In the lower rise areas that I've shown you, most of this is what you already know as an architect, and there is some consultation, outside consultation and verification with some engineers that is definitely prudent and necessary, especially for what you're required to do as an architect and what you want to do for the client. The funding, that sometimes is an issue. If you're in a government-funded program, there is money available there for you very tightly for your services. If you are private clients, so all three of them that I showed, oh no, I take that back. The first two that I showed you were private clients, legacy clients that did pay for extra services as needed, and we're really good at getting a handle on what that might cost and showing that to them well up front, but also being able to tell them what the return on the investment is. So if we have to research hurricane windows for a historic district, and they have to be done in such a way that is not manufactured, then we have a little extra work, a little extra groundwork, and they're okay with that if the return on investment is something that impacts the insurance side of it or the safety and security wise. For those in programs such as Build It Back or other programs, there's a very little bit of money in those programs that are for those additional services, and you have to go through an approval process by which, yes, we're going to provide that additional service, and you go after that money with your client's help, and it's generally not enough. So that's the tough part. So do you, as an architect, you have to look at to make sure that you remain profitable, viable, providing health, safety, and welfare, and the best care possible. So if you don't think you can do it within those bounds, then some of this work may be very difficult to you to engage in. And we've been very selective. To be quite frank, we've had to be, given that is some of the issues that you run into. You can give a certain amount of guidance, but to get fully blown into a project, eyes wide open, there is some extra fees there that either you have to come down in your fees, which I don't advocate for, or you have to be very smart about how you're going about it and see how much money truly there is for you to deliver proper services.
So you do kind of try to discuss right up front that the additional cost of this kind of project?
Yeah, so what's going to come out for that study of the house that we're building, NJIT is going to be doing not just the energy side of it, we're going to engage with them as well as the industry partners to show what the cost differential is. So a lot of what you're going to find with the IBHS and Fortified and some of the other things from the Federal Line Safe Homes is using existing construction materials, but using them in a different way of assembly. So in that prediction process, such as ICF, we've seen documentation from the ICF folks and contractors that have used ICF is that your initial cost is only about a 6% more than what initial stages of framing would be, along with some of the other elements that you have to use. So we're going to verify all of those pieces and get those out to everybody who wants them. As we said, we're going to release all the documents for this process, the plans, the drawings, all the specs, as well as the energy over the course of the next year, and the use, and all of the cost analysis of building, because we want to do this better as well. And so it does cost more. We're looking we are looking that this is a 6 to 8% initial cost, but your return on investment just from the insurance side and longevity of the building outweighs that substantially. And I think those are the numbers that the architects listening, they need that for a business model. And that's what we want to get out of this and get to them. And some of that exists. So I think if you look at some of the resources, you'll find some of that information. But we're gonna provide it as soon as the house is finished and we start getting this information out there.
That's great. I know another issue is some people will have a hard time selling their house in the future if they're in the flood zone. And I've heard of people backing out of house deals because they find out they're in the newly designated flood zone. So again, that's hard. You can't really put a price on that, but just the idea of long-term investment being more secure. Do you have any suggestions on some of these raised houses for people with mobility issues? I would think a ramp is going to be very hard. Elevator probably doesn't make sense.
Yeah, no, that's a great question. And what I didn't get to show you in the document from the Department of City Planning, the retrofit guidelines that had come through. So in each of those cases, they are very distinct about how you can attain accessibility. And within the New York City programs, if I was on this tight lot and that elevation that I showed you shown of the small bungalow in Breezy Point, if that house had required the occupant or the owner had required an accessible ramp or lift, that's provided within the program. It's an exterior lift that's incorporated into or next to the stairs, and is an all-weather lift and can flood. So there is technology already out there that's been used through New Orleans and Florida, all over the place, but we're not so familiar with it here in the Northeast. And when you see these things in operation, you're like, wow, there's an elevator or a lift that actually works in a flooded capacity. And those tight sites, you're exactly right. If I'm going up 15 feet or 12 feet, a ramp doesn't make sense. In New Orleans, some of the projects that we've looked at down there have used the vernacular of the porch and wraparound as a common ramp for 3 or 4 houses together. So you gang together multiple houses and their walks. A couple of slides I deleted out. Similarly, in Delaware, around Rehoboth Beach and those areas, there's most of the housing and hotels and whatnot are already built to these higher elevations, and they've come up with these elevated streetways and walkways and all of those things, and these are residential zones. So some of the best resources that I didn't mention are really looking at places that have dealt with this much longer than here in the Northeast. And so you'll find there's a lot of great pieces out there, not just the technological piece I mentioned, but also, hey, if I'm in Breezy Point and I have houses that are less than 8 feet apart, and you already have these communal walkways with no traffic, how about doing an elevated walkway and with these side yards as ramps so people can attain the right height, proper height? But that's a community buy-in. If you did do that, the CRS system, the community rating system that I mentioned, would love something like that. And there's probably federal funding behind that to make that piece happen. So again, it's digging deeper into what's available to really go beyond, I'm just doing one building, but all of your neighbors are doing the same building. They're doing the same thing. They have to do the same thing based on the flooding conditions. So how do I leverage that with the community to make something happen at a larger scale? Or come back to these ideas of the smaller pieces that I mentioned.
That's great. Yep. We're starting to run out of time, but just to let everyone know, if you have any questions that we don't get to, you can submit them in the survey in the follow-up email. I have one more question I wanted to ask. Do you know how much of the New York City Build It Back funds have actually been distributed to the communities and homeowners, and if you consider it a successful endeavor, and if not, how would you recommend making it better?
Oh, so there's a long answer to that. I don't know how much money has been been allocated. I haven't really looked at that. But if you really consider this, 68,000 buildings were inundated in New York City's 5 boroughs from Sandy, 68,000. Only 10,000 buildings signed up for Build It Back, and I think only between 5,000 and 6,000 of them remained in the program. So I know we're talking about Build It Back, and there's a lot of questions about it. What about the other buildings? You know, so I showed you 2 buildings out of the 3 that were completely private. They went faster. They went generally on budget. The time for them to be built and retrofitted took a lot longer than if Sandy had not happened. So there's a big issue there, and that also is part of cost. So back to the other part of the question about, is it a successful program? I think it could be run better. I don't think it's a successful program when it comes down to how things are progressing with the homeowners. And could it be better? Yes. And I think that's the conversation, that instead of looking at it and saying, it could be better, it should be better, it's a terrible program. This is where we as the AIA need to get our feet wet, and we are in New York. So I'm working side by side with city government how to make guidance better, bring in other colleagues, all of those things. And this is one of those things that we need to look at and say, how do we make this better? How do we make sure that if the AEC industry is doing trillions of dollars worth of building across the nation, why are we changing how it's done after an event? Could we just usher it forward in a much better way? And I understand why it is the way it is, but I think there's a good conversation to make it better is the better question here. And there's a lot of ways to make it better. There's a little too much, in my opinion, too many extra steps added to a process that has been going on for quite a long time as the AEC industry. And I think that's where the crux of it is how do we get qualified contractors, architects moving towards the right direction to build these things back, but also building them back in a way that is sustainable and resilient for the future rather than a replacement. So a lot of Build It Back funding is a replacement house, but it's just elevated. Is it a resilient house? Continuous load path? Is everything strapped down properly? Or does the program pay for hurricane windows? No, it doesn't. Does it pay for shutters? You can shutter your windows for flying debris. No, it doesn't. So if you start to look at those little pieces, we're spending a lot of money to put back housing that is elevated based on the last storm. If the next storm comes in and it's a different storm, which it will be, those houses are no longer considered resilient. The flood may not come, but the wind may come. So there's a lot of, it's a long learning curve, and I appreciate my colleagues that work on it all the time, but it could be a lot better, much better.
Well said. It's definitely a long learning curve. I think we will get there eventually, and I thank you very much for the work that you do and sharing it with us today.
Oh, you're welcome.
And again, everyone, we will be sending a follow-up email with a survey, and you'll be able to download the full presentation as well as the slides, and you'll be able to submit a survey for your continuing education credits. Please submit that by Friday. Thank you very much, Illya. This was great. I look forward to following your work in the future.
Thanks. Thanks, everybody, for having me.
And best of luck to you, and thanks to everybody who helped make this possible. Thanks. Bye.
Bye-bye.